Hi everyone. So we're looking today at kinetic energy. So this is the first of our energy types that we need to do a little bit more focus on and go into in a little bit more detail. As always, you need a pen, paper, and a calculator for this lesson, and you need a quiet space to work. So pause your video, get yourself set up, and once you're ready to go, write down your LO, today's date, and we'll get going. All right, so like I said, this is the first of the energy types that we're going to look at in a little bit more detail. And before we do that, we're going to have a quick retrieval. So pause the video, give yourself a few minutes, and answer these questions. Once you're ready, press play and we'll go through the answers. All right, okay, so what is the law of conservation of energy? It is where energy can be transferred usefully, stored, or dissipated, but it cannot be created or destroyed. What does our term system mean? It is an object or a group of objects. What is work done? Work is done whenever energy is transferred from one store to another. What are the two types of work we talked about in the last lesson? We talked about mechanical work, which involves using a force to move an object, and we didn't talk about it in as much detail, but we did mention electrical work, which involves a current transferring energy. And what is our equation? So you could have wrote it down in word equation, which is work done measured in joules, which is equal to force measured in newtons multiplied by distance measured in meters. You could have also wrote down the symbol equation, which is W equals F multiplied by S. Okay, so let's look at kinetic energy today. So what does our specification say? So again, you can pause the video, take a moment, read what the specification asks you to know. You'll see that they want you to know the equation, they want you to know the units of each of the different parts of the equation, and they want you to be able to manipulate this equation as well. So we're going to look at what is meant by it and we're going to calculate it. So the same as work done. So looking at these images, what do they all have in common? So you've got three kind of different images. You've got a racing car, you've got a tram, you've got a roller coaster. How are they the same? What have they got that is the same? All right, so hopefully you're all shouting at the screen that they all have kinetic energy. They are all moving objects. They are all moving from one place to another. They're changing direction. So again, green box, write it down. Definition, kinetic energy is the energy stored in a moving object. It's quite a simple one. It's the energy that we store in a moving object. All moving things have kinetic energy and station objects have nothing. Okay, they have no kinetic energy. So if something is not moving, if I've got my I don't know, my book sitting on my shelf, it's not moving, it has no kinetic energy. An object has to be moving to have kinetic energy. So, can you think of a few more examples of kinetic energy? So, you might want to pause the video, have a little think for a minute, you might want to jot some ideas down. A few examples of what can we use kinetic energy for? Okay, so by now you should be able to describe what it is. So you should be able to give me a definition. You should be able to give me a few examples that you've just thought about. And hopefully now you'll be able to calculate it. So in order to calculate kinetic energy, we use an equation. Again, this is an equation we need to learn off. So you might want to pause the video now while you write that down. So we use the letter E for energy, and because we have got different types of energy, you will see smaller letters beside the big E, which represent the different types of energy. So in this example, we're talking about kinetic energy, so we use a small k. So capital E, small k is equal to half multiplied by mass multiplied by velocity squared. So EK is equal to half times mass times velocity squared. So kinetic energy is measured in joules, mass is measured in kilograms, and velocity is measured in meters per second. Okay, now when we talk about velocity in that equation there, we're not talking about velocity squared. So be very, very careful. We're just talking about velocity. For this equation, we have to square it. So just to keep that in mind, it is important to recognize that that's being squared, because when we have to rearrange the equation, you will see that we need to then get the square root of velocity if we're trying to just calculate the velocity of an object. Okay, so if you want to pause the video if you've not got that down, if not, we'll move on. So again, if you like using the equation triangle, that is absolutely fine. Write down your formula, do conversions if necessary, fill it in, and show all your workings out, okay? So if you need to use the equation, that's fine. You might want to pause the video now, otherwise I'm going to just move on. So our different equations, you can see here that mass is energy, so kinetic energy divided by a half times velocity squared. Velocity squared is equal to kinetic energy divided by a half times mass. I'm sorry, my PowerPoint has kind of moved everything a little bit on me. But to get velocity by itself, we have to get the square root of this whole thing. Because look up here, we're looking at our velocity squared. So we must get the square root to find velocity by itself. Again, you've got your triangle over here if you find that useful, but you do need to learn this equation off by heart, and you need to be able to rearrange it to get mass and velocity by themselves. Okay, so let's look at an example now. We're talking about a car moving at constant speed. I know that in my fuel, in my petrol, in my diesel, I've got chemical energy. That goes into my engine, a chemical reaction happens, and that causes the car to move. That means I'm generating kinetic energy. My car now moves. So let's look at an example of how we would calculate that. We've got a car, it's got a mass of 700 kg. It's moving at 20 meters per second. So we want to calculate the energy. So we write down our equation, a half times mass times velocity squared. I substitute in my numbers. So 0.5 multiplied by the mass was 700, multiplied by the velocity or speed was 20. So I make sure that I square that 20. So you might want to even write down the second line where you would have the 20 squared, pop it all in the calculator, and I get 140,000 joules. Again, like I said to you in the last lesson, we can rearrange that down to kilojoules. So kinetic energy is equal to 140 kilojoules. Remember that K, all that means is multiplied by 1,000. Okay? All right, so if you'd like to pause the video now and try and do this question yourself, give yourself 2 or 3 minutes to try and get it done. All right, so a cyclist and a bike have a total mass of 100 kg and they have a speed of 15 meters per second. Calculate the kinetic energy. So the kinetic energy, I've given you the equation already. Remember, you won't get it in the exam. You must learn it off by heart. So if I write down, substitute in, I've got 100 for my mass, 15 for my speed, pop all of that in the calculator, and I get 11,250. I do not need to convert this to kilojoules, but I have converted it to kilojoules to show you there what it would look like. So if I convert it to kilojoules, it's 11.25 kilojoules. All right, again, pause the video, give yourself 2 or 3 minutes, and try and answer this question. All right, again, I've given you the equation here. You won't get it in the exam. So we need to rearrange the equation here. They've asked me to calculate the mass. So I need to bring mass over to one side by itself. So that gives me kinetic energy divided by a half times velocity. That's 75. So I had kinetic energy of 75 joules. divided by a half times 50 squared. Pop all that in your calculator and we get 0.06 kg. All right, try these two by yourself. So again, pause the video and try and work those two out. All right, so by now you should be able to describe what is meant by kinetic energy, and you should be able to calculate kinetic energy of a moving object. Again, this was a nice short lesson. You can use free science lessons to go back over all that we've just done. You can use BBC Bite Size, or again, pass my exams. All right, have a lovely day, guys.